Great, thank you so much. My name's Meredith Rawls. I'm a postdoc at the University of Washington, and I work with the LSST data management team. And I want to thank you for the opportunity to speak to you guys today about the Large Synoptic Survey Telescope. We've already heard about a few surveys so far this morning, and I want to focus on something a little bit different, in particular the software that my team is working to build to deal with the large amount of data that's going to come from this telescope. Go to the next one, please. So briefly, LSST is going to come online in 2022 and survey the entire southern sky for a decade. So the idea behind LSST is that at the end of the day, we will basically have a high resolution movie of the sky over a full decade, which I am incredibly excited about. But the ultimate deliverable at the end of the day is really going to be data for people like you to use. This is going to be open and freely available to the community. There's going to be images, catalogs, alerts. I'll explain more about that later. And all of this is stuff that you can use to do science. And I also want to highlight the fact that there's a large number of people behind this project. I am one individual, but there is a large team making all the aspects of this project possible. And this presentation and this mission would not be possible without them. A subset of them are in this picture from this meeting in Tucson back in August that I got to attend. So a few fun facts. There's going to be a lot of pixels in every image, 3.2 gigapixels, in fact. And every image will be a 30-second exposure with a 2-second readout time, which I was really impressed by when I first heard that stat. You can go to the next one. Here's some pictures of LSST, some of which are real, some of which are renderings, but it's under construction. It's really being built. I think this is so awesome because you can, when you're working on the software side of things and you're not physically at the telescope location, it's really cool to see these pictures come in of this actual facility taking shape. So this picture's from late September, and you can see that they have the two parts of the building under construction there. The idea is that the main telescope dome will house obviously the telescope, and then there's also a facility attached to it, and one of the main reasons for having that facility there is so we can re-illuminize the mirror on site, so we don't have to have a big gap in the 10-year survey of LSST in order to make sure the mirror stays sufficiently shiny. Down there in the bottom is an image of the primary mirror, 8.4 meters across, before it was put into a crate for storage, before it will get shipped down to Chile on a boat in the future. Go to the next one. Here is a brief schematic of the camera for LSST. So on the left, you can see a silhouette of a person standing next to this camera. This camera is quite large, a little bigger than your cell phone, a little bigger than your familiar telescope. It has 3 lenses, 5 filters, really impressively gigantic CCD and field of view. If you can go back one slide for me real quick. Over on the left there, that is the field of view, and each of those little tiny squares is 1 CCD, and they are in rafts of 9, and the field of view there has the full moon kind of for scale, to give you an idea of how big each image will be. Go ahead one more. Okay, so that's great. What do we do with all of this data that it's going to take? I could go on and on about how great LSST is going to be and all the different details of how it's being built and all the components, but I want to go a little bit into the software. So this is the worst flow chart I'm going to show you this morning. The basic idea is that on the left, you take a bunch of data, right? You know where the telescope's pointing, you're taking pictures, you probably even have catalogs of what you expect to be there, and you feed that all into this magical box of colors, and then out the other end, hopefully, will come useful things like a catalog of what you have observed, like actual high-resolution images, interesting variable sources, and an alert stream that I'm going to explain in a minute. So the team at the University of Washington is working on what we're calling the level 1 pipeline. And this simply means interesting things that happen on a shorter time scale, on a night-to-night basis or an hour-to-hour basis, things that are changing, which is what I care a lot about as a star person and probably what a lot of you care about. There is also going to be a level 2 pipeline, which is annual data releases of deeper, fainter things, like galaxies and things like that. Right now, of course, we don't have images from LSST yet, but we do have images from a couple other cameras. There's Decam at CTIO and Hyper Supreme Cam at Subaru are both reasonably large cameras on reasonably large telescopes taking reasonably large amount of data. And so we're using those image sets to test the software that we're writing and see how well it performs and get an idea of what we're going to be up against when we actually get LSST images. So here you can see on the right a simple difference imaging scheme. This is probably something you've all done. You get one image from one day and another image from later. You subtract them. Hey, look, there's something different. Maybe we should figure out what that is and if we care about it. So that's a lot of what this level 1 pipeline is going to deliver. Here's a little schematic of how it works. This is probably similar to how you would approach photometry if you were just sitting down at your computer and could actually look at each of the images one at a time. You have your visit, and then you have some template, which is a whole bunch of work is going into figuring out what's the template going to look like that we're going to compare all our visits to. And you subtract them, which is also, how's the best way to subtract things. And then detecting the things that are different is also a big consideration. There's also different ways to do that. How do we make sure we're not finding bad pixels? How do we make sure, differentiate between something that's moving versus something that was there and then wasn't there? Lots of different things to consider. And then we want to say, okay, is this something we already know about? I don't want to rediscover Neptune, right? So we're going to feed in known catalog objects for comparison. And then at the end of the day, we're going to have this object record, this package of information that includes something that changed, where it was, what it looked like, what its history is over all of LSST so far. So what it looked like, from the beginning of the 10-year survey up until now, how this thing has changed, and kind of a characterization of the variability, right? Is it moving? Is it a supernova? Is it a Cepheid? What kind of variability behavior do we see? And we're going to package all this up into what we're calling an alert, which will include a little postage stamp image of that object over the survey's history. So if you can go to the next one. When I first heard about the alerts that LSST is going to produce, I was kind of confused because people were throwing around terms like alert brokers and alert streams and alert, and I was like, what is the alert? Red alert, what? So the way that I like to think about it is if you're familiar with internet services such as Twitter, for example, there is a whole lot of conversation going on all at once on the internet, on these services. And there is no way you are going to be able to digest all that information. You don't care about all that information. There's just too much there. But what people have done is built these ways to kind of filter down what you do care about and make yourself a carefully curated stream of things that are relevant to you. That is the role of an alert broker for LSST. So these are under development by lots of different groups. And so if you, for example, are interested in supernovae, there's probably going to be an alert broker for you. If you're interested in asteroids, there's probably going to be different alert brokers that would filter out all of the stuff coming from LSST and tell you interesting things you would care about there. So this is also under development, but if you, for some reason, did want to download the entire alert stream coming from LSST every single night, you're talking about 60 gigabytes, more or less, of data every single night. That's not the images, that's the alerts. Every single night, if you were to get all the images, it would be 15 terabytes. So you're not going to be doing that. We don't want you to do that because that's just not practical. The idea is that this will help you filter out what you're interested in so you can drill down deeper, be it get follow-up observations or learn more about certain objects. So the software that is going to make all this possible is what my team is working on, and we call it the stack, which you can see a to-scale image on the right there. Super tasty. It's a whole bunch of Python software as well as C++ for some of the deeper stuff that needs, some of the lower level stuff that needs to run faster. We are super close to upgrading all the Python to Python 3, which I was like, okay, whatever, Python version this, that. Turns out that Python 2 is going to stop being supported during the 10-year survey of LSST. So it actually matters a lot that we can upgrade that. So that's super close to done. We also are partnering with lots of folks who are making their own pipeline processing for the data. All of this is going to be public. So if you have your own idea of how you want to process the data, that's what we're calling level 3. It's community-driven pipeline development, and that's also available. If you're curious about the actual software, you want to see how we're developing it in real time, or you want to use a somewhat more stable version of it that already exists, these two websites are great. GitHub hosts all of our code, and it's all public. There's no secret rooms we work in. It's all available. And the Pipelines website is there if you want to have something that's a little more usable. It's still under development, but it's not going to crash. So the documentation is still being written, but it's a good resource for you. All right, so here's a couple examples of the kinds of data products you can expect if you're looking at, depending on what you're looking for. So the main point I want to make here is that on the left, this is something like what the data release would give us, in that on the right portion of the left panel, there was an asteroid that was kind of moving along. You've probably seen this kind of thing if you've added a bunch of images up and, oh, darn, there's a moving thing. Now there's 5 little dots. That's annoying. So we have algorithms that account for that and get rid of image artifacts and things that are moving, so that if that's not what you care about, you can make it go away. On the other hand, if that is what you care about, like the image on the right, we can also make a little movie of how those things are moving. So you might notice that the asteroid, in this case, there's 2 little things there. If you look, there's 2 little asteroids. One of them is saturated. So LSST is going to saturate at about 16th magnitude. So we are going to find the faint things. And then if those faint things are getting brighter, we're going to want folks like you to get on it, because we're not going to be able to get good observations once things get brighter than 16th magnitude or so. So that's an important gap that you guys can help fill. All right, if you want to access some of the LSST data once it begins coming in 2022, this is a friendly user interface that's being developed right now. It's not, you can't download it yet, I don't think, but it's being developed. And the idea is that, again, we don't want you to download all this data. We want you to be able to go to a website and have a portal to see all the stuff that's available. And in this portal, you can make plots, you can search catalogs, you can kind of slice and dice the available observations however you like to help your science. All right, so to wrap up, I want to leave some links up for you. I have one more slide, but I'll come back to this at the end. So there are lots of different places on the internet that you can go to learn more about LSST and to get involved with the work that we're doing. The main project website, just project.lsst.org, will point you to a lot of cool places. There's also a great discussion forum happening at the community.lsst.org website. It's kind of like a wiki, but better, if you will. Where there's a lot of people from within LSST or from the community can log on, ask questions, and help one another with different things that are going on. Again, the code's available, some documentation for the code is available, which is really great. There's a lot of stuff under development, and I haven't even talked much about the specific science goals of LSST, but it's going to do, more or less everything. So that's pretty great. All right, so 2022 is sooner than you think. And so just to recap, the data products and the software that we're making at the LSST are for you. They're not just for us, they're for the whole community. There's going to be this nightly alert stream, these annual data releases, and lots of community-driven options. So please feel free to come and talk to me. I'll be around for the rest of the conference. If there's something in particular that you were interested in doing with LSST, or if you want to know more about a certain aspect of it, I'd be happy to chat. Thanks very much.
Yeah, I was just you're talking about this is big data project, right?
Yes.
How do you archive 50 plus petabytes of data?
A big server in Illinois.
A big server.
Yeah.
In Illinois. Yeah. Is that much storage available currently, or is that?
Oh yeah, it's available. It's not not in everyone's desk, but we don't that's why we don't want everyone to download their own copy. We're gonna basically have one big archive that is gonna live in Illinois. We have a dedicated I believe they're putting in a dedicated cable to actually transmit the data there, because the idea is that all of this alert stream processing will happen within a minute of the actual observation taking place, so that if you want to know about something that's happening in real time, that information will be available.
Wow, that's amazing. How many alerts per night?
Oh, like 10,000 or something? A lot. Maybe more than that? Oh, sorry, 10 million. 10. That's an order of magnitude among friends.
I have a question about the alert system. Will this be similar or based on the VO event system?
That is currently being discussed a lot. So VO events are kind of the starting basis for what we're building, but we're finding that there's some things with VO events that we're not huge fans of, and so there doesn't seem to be any other standard at the moment in the community. If you know otherwise, I'd love to talk to you. So I think what I actually have, my colleagues are kind of working on figuring out, are we going to do like an adapted version of a VO event, or are we going to kind of write our own VO event-esque thing, which will hopefully then become a standard. So that's very much up in the air right now.
Is one of the options for alerts that you're considering for people to be able to give you catalog IDs of objects that they're interested that may suddenly get bright, that may go brighter than your limit? Say a cataclysmic variable that's normally a quiescence at 22, and you want to know when it goes into outburst. Can you select targets and then have, so like create your own custom alert system?
Sure. The short answer is no. The longer answer is I have a cool slide after my talk that you might enjoy. So there are a lot of people working behind the scenes to figure out what the quote unquote optimal way to observe all the things is, because we have all these different filters, we have different science goals. You know, some folks would really like one filter on one part of the sky forever. Some folks would like different filters, different places, you know, over several days. A lot of competing interests. Right now we're kind of taking all these ideas together and working to kind of come up with the best overall observing campaign. But I don't believe there is a plan for, if your favorite thing is happening right now, we are not going to, I don't think, unless it's like, you know, the first Milky Way supernova since forever, right? Maybe we would change for that, but basically it's going to be set. It'd be too bright, that's true.
I have a question about the level 3.
Sure.
Our Chandra experience is that level 3 was one of the key pipelines that we did, because it did lead to the source catalog, which will be used now and forever. It's one of the major products. So you are piping the level 3 through whoever does it. But what happens with the feedback? And is it going to lead to a source catalog, which will be a legacy?
Sure, yeah. So there are plans to make a source catalog. I didn't emphasize that, but
how? How is the level 3 if you're not doing
Sure.
level 3 and it's kind of distributed?
Sure. So there will be a source catalog as part of level 2, but then we certainly like so. So the idea is that right now we are working really hard on level 1 and level 2, because we need to have the basis built really once the data starts coming in. But we are really excited to see what we didn't think of that other people will build given the tools that are available.
So you have a feedback channel in place from the level 3 that the other people are doing.
I think that's the idea, yes.
One more question?
How far north in declination will the system typically tend to operate?
Oh, you ask hard questions. Well, here's a nice picture of the sky. It's got numbers on it. Oh, yeah, I'm hearing people say plus 40-ish. That sounds reasonable. Not too bad. Little overlap with you folks.
Okay, well, thank you very much, Meredith.
Thank
Appreciate
you.
you coming.